So this was a pop quiz, the weekly pop quiz, which was related to the atomic structure and the moles. The atomic structure and the moles pop quiz 1. In question 1, transition elements found in the middle block of a periodic table. Chromium has several isotopes. Manganese has only one isotope. What is meant by the term isotope? So what is the meaning of isotopes? Isotopes are atoms of same element contain same number of protons but different number of neutrons. No, same number of proton and electron, but different number of neutrons. Neutron number is different. Proton numbers should be same. Electron should also be same. State the nucleon number of manganese. So to work out the nucleon number means like the mass number of a manganese. So what you have to do, you have to use a periodic table for that. So when you check the periodic table, what is the nucleon number of manganese? Nucleon number of manganese according to this periodic table. Yeah, that's right. It is 55. You can see here manganese. So you will find it is 55. So you will write 55 there. Then complete the table to show the number of protons, neutrons, and electrons in a chromium ion with a charge 3+. So first, how many protons will be there? Because 24, so this will be 24 protons. How to work out the nucleon number? You take a difference, it will be 52 minus 24, which is? So 54 minus 28. So this will be equals to 28. Because it is charged, it has a +3 charge, means it has 3 more protons or 3 extra proton. So how many electrons should be there? It must have 21 electrons. So if a charge is positive, you subtract that number. If a charge is negative, you add a number to the electron. Like if a charge is +3, we subtract 3 to get the electron. If a charge is -3, we add 3 to get the number of electrons. The discussion was related to moles. Question 2, the titration is there. 25 cm cube of 0.08 moles per decimeter cube aqueous potassium hydroxide is neutralized by 20 cm cube of a sulfuric acid. Calculate the moles. Because we have the volume and we have the concentration, so we can work out the moles equal concentration time volume. The concentration is 0.08 and the volume is 25. You divide it by 1000 because volume should be in dm cube. So 0.08 times 25. What's the answer for this? 0.002. Okay. So the answer here is 0.002. Determine the number of moles of H2SO4 that react with KOH. So how to work out? Because whenever we solve the question related to moles, the first part, if we solve by using a formula, the second part we'll use a ratio. So what ratio we will take? We'll take a ratio between potassium hydroxide and sulfuric acid. So according to equation, the ratio is 2:1. So if you have 0.002 moles How many moles of H2SO4? It will be X. So it will be 0.002 divided by 2. That will be 0.001. After getting the moles, we need the concentration. So how to work out the concentration? Concentration is moles divided by volume, because moles is concentration time volume. So concentration is 0.001 and divided by, moles are 0.001 divided by volume, the volume of sulfuric acid, which is 20, or we divide by 1000, 0.02. So 0.001 divided by 0.02. Is it 0.05 or 0.05? 0.05. So it is 0.05. That will be moles per dm³. That is the concentration. Now we can convert the concentration from moles per decimeter cube to grams per decimeter cube. This was 0.05. If you want to convert the concentration only, what we simply do, we multiply by the molar mass. Molar mass of sulfuric acid, H2SO4, you have to use a periodic table. Hydrogen is 1 and there are 2, so multiplied by 2. Sulfur is 16 plus oxygen, sulfur is 32. Yeah. Sulfur is 32, 16 is a proton number, so 32 the mass number, and oxygen is 16 multiplied by 4. So 32 plus 2, the total sum will be 98. So the sum is 98. So we multiply this by 98. So 0.05 times 98, what will be the final answer? 4.9. So that is equals to 4.9 grams per decimeter cube. So first we use a formula, then we use a ratio, then we again use a formula. And then if you want to convert the concentration units from moles per decimeter cubes to grams per decimeter cube, we multiply by the molar mass.